All right, so for this one, it says Jerry measures the time it took for a ball to be dropped from a balcony to hit the ground. His stopwatch reads 2.2 seconds. How high is the balcony? So there's a building. So the first step is always draw the picture, right? So over here, there's a building. And somewhere, there's a balcony. And Jerry drops an object from here, right? And it goes down. And let's assume the building has a happy little lawn. Now the time, so as we're drawing the picture, we got to list what we know. Well, the time that it takes to fall is 2.2 seconds. What else do we know? The acceleration due to gravity is negative 9.8 meters per second squared. Right? So it's in free fall. Is there anything else we know?
The initial position.
Okay, what do we want to make that? You don't know? So we can make it 0, right? So, and we'll see, we're going in the y direction, so let's define some things. Going down is negative, going up is positive. If I want, I can make this y sub 0. So let's just call that 0, because we want to know how high this is off the ground. Okay? So there's two ways you can do it. I can put the 0 here, or I can put the 0 here. Doesn't really matter. If I wanted a positive answer, I'd probably make the 0 down here, and then that would give me this one. So it doesn't really matter how I do it. So we'll just make this 0. Now, if I make that 0, that means my answer will be negative, and the negative is the direction of the displacement. So they're probably just going to want the positive, so it doesn't matter. What about the velocity the instant he lets go? 0. So my initial velocity, and this will be in the y direction, will be 0 meters per second. So we have a lot of information, right? So now what we got to do is we got to think through ourselves, is there an equation that gives us, well, what are we looking for? Well, we're looking for y final, right? Way down here, right before it hits the ground. Right? That would be my y, my final y value. So in your notes, there's an equation that looks like this. It says the final position y is equal to the initial position y plus the velocity in the y direction times time. Now, if they use a, you put in the negative, but this is also g 9.8 meters per second. So depending on the formula you use, in other words, if you say g, it would be like minus 1/2 g t squared. Okay, so my final position of the object is going to be 0 plus, and this is another thing that's interesting. This is the initial. This is Vy initial, so, but it's 0 regardless, times the time, which will be 2.2 seconds, minus 1/2 times 9.8 times the time, which is 2.2. Remember, the time has to be squared. So really what's going on here, this goes to 0. 0 times anything is 0. So my final position is actually equal to just this stuff over here. So I can plug that into my calculator. I just got to pull up Desmos. So I'm going to say 1/2. So 1, actually it's negative 1/2. So let's do it this way. Negative 1 half times 9.8 times 2.2, and then I need to square that. Now I've got a negative 23.7 roughly, right? Meters. So what that's saying is that this object is displaced 23.7 meters in the negative direction. So if you were to say how tall is the balcony, well, how high is the balcony? Well, it's the positive of that, right? 23.7 meters. Is that one of your options?
I think it'd be 24.
Yeah, you can round it up to 24. Yeah, you know why? Because of the significant digits. Yeah. Okay. So yeah, let me put that in here too.